Okay, so today what we're going to do is we're going to continue some of the basic ideas in algebra. And I want to be serious for just a second here, guys, and talk to you about something that really does happen and is really important. Many students do well in mathematics until they reach a certain point. And that certain point is usually where the mathematics becomes algebra-based, where you leave behind arithmetic and start moving toward algebra. And it doesn't have to happen. But you have to start making sure that you understand the language of algebra. And we did that by last time talking about what is the only one thing that makes algebra different than arithmetic. What do they introduce? Letters. The letters, which are called variables. Excellent. And they're called variables because their value can vary depending on how they're used in a sentence, right? How many operations?
4.
4. Still 4 operations. Still going to do those same 4, but they may look a little different because of the introduction of the new system. Remember that in algebra, we no longer have just numbers. We have what are called algebraic. It starts with a T. Terms. There you go. Excellent, guys. And each term has how many parts? 4 parts. So let's begin by writing down that part. So we know that it's built up of terms, and all terms have 4 parts. We're going to write this down just about every day, because if you don't understand it, then you're never going to understand algebra.
And that's not okay.
What's the first part of every term? Oh, be careful. The sign. Those pluses or minuses that begin in the front, which tells you that every time you see a plus or minus, you know it's the beginning of a new term. What's the second part? The coefficient. Good. And remember, the coefficient doesn't mean number. What does coefficient literally mean? Multiplier. There you go. A coefficient literally is a multiplier, but for a term, the multiplier is always a number. Right?
Just for one term?
Okay. Just for a term. Coefficient?
And so like in like term 1 is called
There you go.
Wait, excuse me, is it only like this term or like next term?
No, for a term, an algebraic term. For an algebraic term. Okay?
I never really understood what a coefficient is.
The coefficient
it's a multiplier.
is a multiplier. So, say for example, we have the term 4x.
Excuse me.
Hold on a second. The 4 is the multiplier for the x, right? We know they're multiplied because they're side by side like that. Remember we talked about the operations last time?
Right.
So, the 4 is the multiplier or coefficient of it.
Yeah.
Now, you can also have the same thing with parentheses. The A is right up in front of the bracket. Sorry. The A is right in front of the bracket, which makes it a multiplier or a, what's another word for it? Coefficient. Okay? So it means multiplier. Third part of every term, guys.
If it was like AB, there would be a coefficient.
You bet. If it's AB, what's the coefficient of the B?
1.
The A. Because it's a multiplier. Right?
So the multiplier isn't always a number. The coefficient is.
Right. But in a typical algebraic term, right, where you have like 4x or something like that, it's typically a number. Right?
Okay, yeah.
Okay. What's the next part? Do you remember? The base. And the base simply means the variable. Okay? Got to memorize these, guys. And on the fourth part, whether you see it or not, there's always an exponent. Excellent. Exponent or an index, right? Or power. Lots of different words for it, but it means the same thing. Now, also, it's critical that you understand what each part does. These first 2 parts literally tell you how many of something that you have. It's like saying I have 4 cars in the parking lot, right? 4 tells you how many of them. Cars tells you what they are. And the base and exponent literally name the term. They tell you what kind of term you have. Okay? And so the first thing I want you to do is I'm going to write down some terms, and I want you to tell me the name of the term. In other words, what kind of term it is. And I'll do the first one for you. So let's say we have negative 4x. So because the x is the base, this is called an x term. Okay? An x term. Whatever the base is, that names the term. So then, if I have this, what kind of term is that?
Y term.
It's a y term, exactly. Excellent. Okay? Now be careful here. If I have this, what kind of term is that?
A variable.
It's an AB term. So you can have more than one base, more than one variable. Okay? All right? Now, but also remember, you can have an exponent too, can't you? What kind of term is this?
X term.
Well, not just x, but x to the third term, also known as x cubed. So remember, you have to include the exponent if there is an exponent. Right? Look good?
Yes.
Okay.
Thank you for
The next thing we're going to talk a little bit about is signs. Remember, signs mean either those plus or those minuses. Now, we typically see a plus or a minus, and we think of a plus. The pluses or minuses are being either addition or subtraction. But in algebra, we have to be more careful because those pluses and minuses are now the signs of the term. So instead of saying add or subtract, we combine that into one word, and that is actually combine.
Not gnarly.
All right? Because what we're going to do is, guys, we're going to combine them by using either adding or subtracting. Because of the sign rules, right? Because of the sign rules, you have to be careful. Because sometimes something might look like addition, but you actually end up subtracting. Other times, so sometimes it may look like addition, but you actually subtract. And it may look like subtraction, but you actually add, depending on the signs of the numbers. So we need to talk a little bit about that operation of combining. So do you see why we don't think of it as add or subtract anymore? We think of it as combine. And there are two rules for combining
You add it.
that you need to know. Okay? All right. The first rule says that if the signs are the same. Now, what do I mean by if the signs are the same? That means that both numbers I'm combining are either what sign? Both positive, or they're both what?
Negative.
They're both negative, right? But they have to be the same. So they have to either be both positive or both negative. If that's the case, then what you're going to do is you're simply going to keep that sign. The sign of your answer will be either positive or negative, depending on how they start out.
Yes.
Okay? And then the second part of that is that you will add the numbers together. Okay? So if the signs are the same, what do I do with the sign?
You don't kill it.
Keep it. Keep the sign. What do I do with the numbers? Add them together. Okay? Good. Now, there's a second rule. If the first rule starts out, if the signs are the same, what's the only other alternative? The signs will be different. Yeah. if the signs are different.
Can you give us examples?
Of course, we're going to go through lots of examples. If the signs are different. Now, what does it mean to be different? That means one of them will be positive and the other one would be what? Or the first one could be negative, but the second one would have to be positive. Right? No, well, positive. Okay? So, different signs. If that's the case, we're still going to keep the sign, but what we're going to do is we're going to keep the sign of the larger number. Exactly. Now, I know that on a number line, if you have negative 12 and positive 2 is really bigger, right? But we're not worried about the sign here. What we're just looking at is just the number. It's something called the absolute value, just the number part. So what would be bigger, a 12 or a 2?
12.
The 12. So the 12 then tells the other number what sign it's going to get. Okay? So the bigger one always wins. Okay?
Yeah,
And then...
like when I'm at Eggman, it's small combining.
Okay?
I'm going to just go, and
So-
Eggman's dead.
Now, the second part of that is, right? Now, have you heard the word difference before? What operation do you associate with the word difference?
What's the difference?
Subtraction, exactly. And so that's what you're going to do to the numbers. You'll subtract the numbers. Okay? And those are the two rules for combining. Okay? And you have to memorize them. You cannot get things right without having the right signs. In algebra, everything has a sign. Not always going to have them to read with. So here we go. So let's look at some examples, and we'll just do these together. And listen to how I ask the questions, because that's the way you need to get it into your mind. So let's say we have negative 9 plus 2. Now, if you look at this looks like an addition problem, doesn't it? But it's not. Because the first thing we want to do is look at the signs. What is the sign of the 9?
Minus.
It's a negative. What is the sign of the 2?
Positive.
Positive. So in this case, the signs are the same or different? Different. Right? Which means that I want to keep the sign of which one?
The 9.
The larger number, right? And 9 is bigger than a 2, isn't it? And so what is the sign of the 9? A negative? Well, that means your answer is going to be a negative as well. No, be careful. Your answer will be a negative as well.
-7.
Now, since the signs were different, I'm not going to add them. I'm going to what?
Subtract them.
Subtract them. So what is 9 minus 2 going to leave me? 7. So my completed answer is minus 7 or negative 7.
Why could you just think
Right.
about it and not have to do
Negative 7. Okay? All right. Let's look at some more. Say we have negative 3 minus 21. We're going to combine these. And the reason you know it's combining is there are no brackets. There are no exponents. It doesn't mean multiply or divide, right? There's no symbol for multiply or divide. If it's not one of those, then it has to be combined. That's all that's left. And in order to combine, I need to look at the signs. What is the sign of the 3? Negative. What's the sign of the 21? Negative. Are the signs the same or different? They're the same, right? So the signs are the same. So that means I'm simply going to keep the sign. So what sign are they both right now? Negative, which means my answer is going to stay negative. And then what to the numbers? Just simply add them. What's 21 and 3 make? And so my completed answer is negative 24.
Plus 2 minus 8.
Plus 2 minus 8.
Yeah.
Okay, what's the sign of the 2? That's all right. I can go back. Okay. So we'll just do it here. Plus 2 minus 8. What's the sign of the 2? Positive. What's the sign of the 8? Negative. So is that the same or different?
Different.
So I'll keep the sign of the larger. So is the larger one the 2 or the 8?
The 8.
8. And its sign is what?
Minus. Negative.
So that means my answer will also be negative. And then I just take the numbers and subtract them. What's 8 minus 2 make?
6.
So my completed answer is negative 6.
Plus 5 minus 3.
Okay. Are the signs the same or different? Different. So I'll keep the sign of the larger, which in this case is the positive. And what's 5 minus 3? 2. Now, this does bring up an interesting thing, though. Notice my answer, plus 2.
You don't need that plus.
Exactly. I don't need the plus in front of it. But if you are going to be, guys, if you were going to say this number, right? So I don't need to write the plus, but if I'm going to say this number is positive 2, not just 2. You don't have to write the plus, but you really need to start to say what kind of number it is. Because from now on, you're going to be dealing with signed numbers. So you need to know, is it positive, is it negative? If you remind yourself to do something over and over and over again, are you more likely to remember it or less likely to remember it?
More likely.
Exactly. So the more you focus on it, the more likely you are to remember it. Okay? So, ready for my question? Hold on, guys. If the signs are the same, what do I do with that sign? Keep it good. And what do I do to the numbers? Add them. Excellent. If the signs are different, then what do I do with the number? What do I do with the sign? Keep the sign of the larger and do what to the numbers? Subtract them. Okay? Very easy. Very easy, but critical to know. All right. Now, let's talk a little bit about combining like terms then. Now that we know how to use our sign rules, we can then think about it as combining like terms. We know what terms mean. Algebraic terms mean there's some numbers, letters, etc., right? Some combination of numbers and letters. But when we're combining like terms, we first need to determine what a like term is. And like terms are terms that have exactly the same base, which is the variable, and something else though. Exponent. There you go. The same base and exponent, right? So, and they can be combined. Okay? To combine, the first thing you want to do is determine the sign. Signs are always first, so do the sign first.
Wait, base is the number behind it.
No, base is the variable. Right? Remember a while ago we had the different bases? So this is an X term, this is a Y term, this is an AB term, an X to the third. The base is the variable and the thing that names the term.
And the exponent is the number above the...
Right. Mm-hmm. So, first you'll determine the sign. Second, you'll combine the coefficients. So, you'll combine the coefficients depending on the signs, right? Sometimes you'll add them, sometimes you'll subtract them, depending on the signs are the same or different. And then what you'll do is you'll simply keep the base and exponent. That part won't change. It's just like saying I have 2 cars and 3 cars. I have 5 cars. The kind of objects that you have don't change. It's simply the number of them that changes. Right? And it's the sign and the coefficient that tell you how many of something you have.
Change if you only have 5.
Okay. So, all right. So let's look at a couple. Say I have negative 3x plus 5x's. First of all, these are variable terms, right? So I need to combine them, but I can only combine them if they are called what? Like terms. What kind of term is this first one? An x term. Excellent. What kind is the second one? An x term. Since they're both x terms, are they both like terms? Yes. So that means I can combine them. So first I need to determine the sign. Are the signs of the same or different here? Different. So I need to keep the sign of the bigger one. So what's bigger, 3 or 5? So that means my answer is going to be a positive, right?
Yeah.
And since the signs are different, will I be adding or subtracting the numbers? No, the signs are different, so I'm going to be subtracting. So what's 5 minus 3 make? 2. And since they were x terms, they stay x terms. And that's it. Okay?
Do you have to do something with the x?
Nope, we don't know what x is. No, you can simplify that to simply 2x. But remember, if you say it as positive 2x. Good job. All right, let's look at this one. 7x plus 3y minus 2x's minus 10y's plus 3x squareds.
Whoa.
There's a lot of terms. Does that matter?
No.
Not at all. Because we're just going to be looking at things that are like terms. So what is my first term? The first term is 7x. So what kind of term is it? It's an x term. If looking across, do I have any more x terms? Yes, I do. What is it? Negative 2x's. Good. Do I have any more x terms? Well, what about that positive 3x? Yes, there you go. Because of the index or the exponent, if that makes it a different kind of term, right? So they're not like terms. So that means I can combine these two. That's a positive 7 and a negative 2. So are the signs the same or different? Okay. Or hold on, answer my questions. Are the signs the same or different? Different. So I'm going to keep the sign of which one?
7.
The 7, which is the bigger one. So it's going to be a positive. And 7 minus 2 makes 5, and they stay x's. Good. I've done with my x's. What kind of term is my next term here? A y term, guys. A y term. Do I have any more y terms? One more right here, the negative 10y's. So I can combine those. Are the signs the same or different? If the signs are different, do I add or subtract? Well, first of all, I keep the sign of which one? The bigger number. No, because this one's positive. The 3 is positive and that's negative. So I'm going to keep the sign of the bigger and do what to the numbers? Subtract them. Perfect. Right. And this one, there aren't any more of those. So, guys, so all I'm going to do is simply bring it down. Now, the only thing I would change, if I changed anything at all here, is I don't really have to have that plus in front, right? Okay. And there is your completed answer.
Why would you have
So we can't simplify it.
Why would you have to have that plus 3? Why would you not?
Because you can't just leave terms alone, right? If you have an apple and two bananas and an orange,
But why did you
you're
say
still going to have every one of them when you're done.
But why did you say I don't need the plus?
I don't need the plus in front of the 5, right? So you don't need that plus in front of that 5 there. You have to have it everywhere else, right? You have to have these signs But you don't have to have the 1 in the very front because we can just assume it. Now, what about if I have this? Like terms or not?
No. Yes. Because it's in alphabetical order.
There you go. What is it, Charlotte?
It's A, B, because 10, B, A is supposed to be in alphabetical order.
Exactly. Remember, we've talked about that when you have more than one variable, you put them in alphabetical order. And this is one of the reasons why, is because it's too easy to say they're not like terms if you don't have them written alike. So then, are the signs the same or different?
Same. No, wait. Or not the signs. No, not the signs.
Different signs, right? So the 10 is the biggest one. So what's the answer going to be? What sign? Negative. And 10 minus 4 is 6. Negative 6, what? AB. So watch out if you have more than one letter. They may try to trick you by putting them out of order. Okay? How's it look?
Wait, will you last change that VA?
Yes, you can just switch it around. Because remember, multiplication can be done in any order. What's 2 times 3? What's 3 times 2?
6.
So because they're connected with multiplication, you can write them in any order you want to. But we prefer alphabetical order
Do you
for
just
them.
assign something, or does it just randomly do it at random
Okay.
time?
All right?
We just got another intuition code.
I just
From what
wished
language?
it to happen. All right. So there we go. So